Hello everyone, my name is Maxence Rube. I'm a PhD student from the University of French Guiana in France. And today I will present you my work on a behavior-descriptive model of love wave sensor in liquid medium for circuit design and analysis with QUCS Studio. First, I would like to thank the IEEE committee for the organization of this year's conference. In this work, we try to use different equations to obtain a descriptive model for source sensor for QUCS Studio. This simulator can be used for basic RF and circuit design and is really similar to the ADS software. However, QUCS Studio and this model are completely open source and free to use. We integrated both the response of the sensor in the air and the response of the sensor in liquid medium, and the model can be used to simulate both mechanical and electrical behavior of the source sensor. But first, let's talk about the real love wave sensor. Love waves are surface acoustic waves, which mean that they propagate exclusively at the surface of a material. In our case, our device is composed of three parts: a piezoelectric crystal of 80 quartz, a thin layer of silica which guide the acoustic wave, and two interdigitated transducers. Basically, by electrically interrogating the input transducers, we create an acoustic wave, which will propagate through the device. The acoustic wave then interacts with the medium at the surface of the device, and we will see its properties change following the mechanical characteristic variation of the medium. Then, the acoustic wave is converted into an electrical signal, which can be used to estimate the acoustic sensitivity. Our modeling strategy is quite simple. First, a set of analytical models help us to estimate some characteristic constants of a love wave device, following some geometrical or material choices, such as the IDT wavelength. These models help us to estimate the love wave celerity and the mechanical sensitivity in liquid medium. These constants feed the QUCS model descriptive equations, which then can simulate a behavioral model in the frequency domain. This model can then be used to do some circuit design. A simple example is presented here for the response of the model in some measurement in the air. The block here contains the descriptive equation here, and a resistance and a capacitance simulates the purely electrical part of the input impedance of the sensor, right here. Here, the simulated circuit is similar to a VNA characterization. You can observe that the input impedance and the transmission parameters are in good accordance with real measurement. Then we try to also take into account here the behavior of the model in a liquid medium for an increase of the viscosity of a liquid at the surface of the device. You can observe that both model and the measurement are in good accordance for the change in the magnitude and phase of the transmission parameter S21. In conclusion, the model gives some really close results and could be used for a large panel of application in the circuit and system design using source sensor. However, the model would also gain in accuracy by using more complete analytical or finite element models to obtain the characteristic constants, but also more powerful descriptive equation, for instance, to take into account the effect of a sensitive layer at the top of the guiding layer. Thank you for your attention.